Hi, I'm Kevin Hoyt, Platform Evangelist with Adobe, and welcome back to this session of RIA problems. Now today I'd like to talk to you about character formats. You might say, how can a character format, a character data format specifically, be a problem? Well, let's take a closer look. If we step back to kind of thinking about what makes up a character, it starts off with a bit. A bit is a single value. It's either on or off, 0, 1. A byte is 8 bits. Now, the permutation of those different 8 bits can give you 256 possible values. That generally is what we think of as a byte. Now, there are certain character sets which represent multiple bytes, double bytes. But in this case, let's just assume that a single byte, a single character, is represented by a single byte. That byte with its 8 bits can represent 256 possible values. So that way we're kind of playing it conservatively, which is going to be valuable when we come to the rest of this segment. So if a character is 8 bits or 1 byte, it's interesting to note that the ASCII format actually uses just 7 bits. It doesn't actually use the full range, which gives it only 128 characters that it can display of the 256 possible combinations. So if you're using just an ASCII character set, then you might even be able to slim it even more conservatively. But for the purposes, again, of this demonstration, we'll be talking about 1 bit, or 8 bits, 1 byte equals 1 character. So let's take a look at some data. Here's a very simple CSV data set of 5 rows, and it includes a header. Now, again, if we consider each of these characters is roughly represented by a single byte. So the header on this particular CSV data set is 25 bytes, it's 25 characters long. And then the average row length, while it differs slightly depending on the name and the data set, the average row length is about 217 total characters for the data. So that's a total of 242 bytes with the header and the data itself, and that gives us 242 bytes to send across the wire. That doesn't seem like much. But the problem is that most applications don't stop at just 5 records. Most applications have many, many more. Let's take this kind of to its logical conclusion. What happens if this CSV data set becomes 5,000 rows? Well, 5,000 rows times an average row length of 45 will give you roughly 219K. So 219K. Now that data coming across the wire seems a little bit more imposing. We have to wait some time for that to come across the wire. So that's a problem. Now, not everything is CSV, and in fact, many times today in this world of services-oriented architectures, SOA applications, especially as it applies to RIA, most of the data is in XML format. Now, this represents actually a bigger problem because it's not simple commas, it's markup, a whole set of additional characters, bytes, that separate all the different values. So in this case, I've taken one of the example records from the previous CSV data set and made it into an XML representation. And in this XML representation, 5,000 rows, that's what we used earlier, which cost us 219K. Here in the XML representation, that 5,000 rows equals 673K. 673K, that's really growing for just 5,000 rows. And again, 5,000 even really is still small compared to what most enterprise applications will need. Now, if you think about taking this to the next level, sometimes you might say, oh, well, SOA architecture, web services, SOAP and WSDL, right? If you're using SOAP or WSDL, that's just more XML. And I'm not saying that there isn't a use case for SOAP and WSDL and the related technologies. Certainly is a place and time for those, but the basis of SOAP is just more XML. So more XML means more character bytes, means more data has to go across the wire. Now, the common kind of JavaScript-y way to take care of this is to strip out all the excess. Go as slender as you can. And here I have a representation of using JSON, so JavaScript object notation, to strip out as much weight as I can to make it a very basic data set. Well, 5,000 rows of this guy is 483K. It's actually still more than just using CSV outright. 483K for a 5,000 row JSON packet that describes a very basic data set. Now I know we can take the next logical step and use compression at the client and the server to squeeze that data down and get rid of the duplicated characters and just use numbers to represent those offsets. And that squeezes us down a little bit more, but you'd be surprised at just how problematic that can still be. Let's take a look at a graph. If you look at the 5,000 records with the web server compression on using these variety of different data sets, you can see that for XML, we're looking at just about 48 or so K. For SOAP, we're looking at almost 50K, and for JSON, we're still above 40K at about 42K for 5,000 rows of this particular data set. So how can we fix this? Character formats are clearly a problem, allowing us to scale to our maximum capability, but how can we fix this? Well, the answer is move to binary. Now, there's lots of different approaches for binary communication between the client and the server. One of the most common ones you might hear about in the Flex and Flash world is remoting, or AMF. And just as an example with the 5,000 records, so 5,000 records in binary, or AMF, will run you about 30K, 28K. So you're almost a full 20K off of what it would take SOAP. You're more about 15 or so off of the XML format. So 15K for 5,000 records, keep taking that up to 1 million records, right? And at this point, you're going to start saving yourselves quite a bit of data and bandwidth by going to a binary data format across the wire. So that's character formats in this series of RIA problems. I hope you'll join me again next time. Until then, I'm Kevin Hoyt.